Okay. So today we have a set of discussions. So we'll straight away get into the topics without any due delay. Okay, hope my screen is visible.
Yes, sir. This is
Great, thanks. Audio unable to hear. Karthik says, is it so, Karthik? You're unable to hear my audio? Hello. Others are able to hear me, right?
Yes, sir.
yes, sir.
But
We can able to hear.
okay, just a second. Let me. Okay. So I guess in the last class we discussed about the detailing of the general purpose functional interfaces, right? So we saw some functional interfaces, consumer, and the other families are predicate and supplier. So we'll get into that one by one later. But before that, I would like to take you to another concept called method referencing. Okay, this is another important topic in Java 8. So it's good to understand the topic of method referencing. Now, so what exactly happens in the method referencing is okay, yeah. So the concept is called as method referencing, and we have a specific operator for it. And the operator, uh, Karthik, are you visible? I mean, are you able to hear me?
Yes, sir. Now audible.
Okay, great. Yeah. Probably you would have used the method referencing before, or probably you would have seen that kind of operations. Probably if you would have worked on some of the projects based on Java 8. Others who are pretty new, then probably you have to stay more attentive. So we use a method referencing operator colon. Okay, double colon it is called as. Please make a note of it. Double colon is double colon represents whenever you come across this syntax carrying a double colon, you can quickly recall them as method referencing. Okay, so that is what is all about. But what is the use of method referencing? Okay, that we need to understand, right? So why we need to use method referencing? Uh, so far we were seeing different styles of lambdas, right? So here, this is also going to enable lambda, but this will further reduce your lambda syntax. Lambda syntax can be further reduced. Okay, so that is the need of method referencing. Only in lambda you can able to use method referencing. When you are able to write a lambda code, then you can make use of the method referencing operator. Have you ever seen this kind of an operator before in any other language? We have. And there we see them as a scope
Scope resolution
resolution.
operator.
Yeah, scope resolution operator, right? So in order to quickly remember, Okay, but that scope resolution operator is all used for resolving your multiple inheritance in C++, right? So we use the super class, the specific method by using the class name and call the method. That is to resolve the conflict. That's a different story, but the style is similar. There also it's double colon, here also it's double colon, but here it is technically called as method referencing operator. Method referencing is a concept, and in order to achieve the method referencing, you need an operator. Okay, and the operator is double colon. Is this clear? What is the use of this? This is applicable only when you write lambda syntaxes, and by using the method referencing operator, we can still further reduce the lines of code. How we can do that? Let's go back to the code that we have already written in the last class. So this is what we were working around, right? Sydney, USA, German, London, and we were trying to convert them into an uppercase, and we wrote this list of countries uppercase by using a for each and then taking one element by element as an input. What is the parameter for the for each that we discussed? Is none other than your consumer, right? It consumes and then you print it. That's all. Consumer is only for input. Supplier is only for return. Function is for both input and output. Predicate is for input, but return is Boolean. So in this case, the style of code, okay, the code what you're seeing here can be further reduced. So how we can reduce this code? How first let's run this and see what's the output, since we saw a couple of days before. So what is the output? The output is all about uppercase, converting the given country names or the city names and making it to be appeared in a uppercase character, right? Uppercase string. So this is the actual job, and we understood what is the use of and then method and compose method. The difference between compose and then we saw in the last class. Now the and then is for combining two consumer, the consumer that we created. That's what we saw, and the method that we use there is accept the countries. So now in this case, the idea is I want to convert this into this lambda should be further converted into something like this. Consumer list of countries uppercase. Yeah. Now, if you look at this style, this part of code can be further fine-tuned, right? So we are using something called list countries uppercase dot for each and then string country. This can be removed. Okay. Now, what is it we are trying to do here is we are just trying to print the country, right? That's all we do. We are not doing anything other than that. So how we can fine tune this piece of code, this particular lambda expressions. Okay. So inside this for each method, I'm sorry, the for each method itself is taking a consumer. So inside the for each, we can just use directly system dot out. Now you can see the operator that I'm using is the method referencing operator followed with print ln. That's all. This line what you're viewing here, right? The line what you're viewing here and the lines what you're viewing here, more or less it's the same lambda expressions, but it's more shortened. We are shortening the lines of code by just using a scope method referencing operator. Okay, so the method referencing operator is acted on top of the object. Okay, it's an instance method referencing. There are different types of method referencings we have. The one what you're watching right now is the instance method referencing. So instance method, correct? The method what you are accessing, the println is a method, and this is accessed on top of out. So it is called as an instance method referencing operator. Instance method referencing, and we are using the method referencing operator. I'm not sure how many of them have seen this. If you have already seen, yes, of course, this is a method referencing operator, but this is a style of instance because we use out. Now, what it does is this line. So this is the one, right? This is the one which takes the country as an input from the list. The for each method will iterate the element one by one, right? So what we have as a first input, Sydney. What this list is carrying? The list is carrying Sydney, USA, German, London. So what this list will do, what this for each method will do, the for each method will take the input from that specific element. Okay. So like for example, just a second, I have some challenge in my monitor. Yeah. So for each method, the for each method will take the Sydney as an input. Okay. And pass it here. So the country will store the Sydney, right? This is all in uppercase. It's already been converted, right? So the Sydney is going to be printed. Now what I'm saying is the same job, the same job. Now with the help of method referencing operator, what happens is the same Sydney will be taken and handed over to this println method automatically as an argument, right? So we need not write the parameter. Okay, there's no need for writing the parameter. And then we don't need to expand the body, and then we don't need to say system.out.println and pass the country. Anyways, it is understood that it's going to carry a string as an argument, and that string need to be printed. That is the job. That is a job. So we can quickly achieve that with the help of method referencing operator out here. Okay, so that is what is happening here. But more interestingly, we need to study this from the scratch, right? So then only we can understand the major usage of this. Okay, there are different types of method referencing operators are there. So henceforth, whenever you want to print something in iterating a collection by using the for each, don't go for writing a consumer style of code like this, consumer style of Lambda code like this. You can write a consumer style of Lambda code with the help of method referencing operator. Is this clear? Any questions you have? So only one argument, right? It's a consumer parameter. For each method takes what as an input? Consumer, right? So the consumer takes how many input in the accept method? Only one, right? Only one. So one parameter is passed, and that parameter is printed. Any questions? If you have any questions on this, please let me know. We'll see one more way of understanding this method referencing operator shortly. But these are different styles. So we need to separate them. You will not use dot, system dot out dot you will not use. That println method is the final call. And for that println method, the parameter will be automatically forwarded. That's the power of method referencing operator. It has an intelligence. The intelligence level of the method referencing operator is according to the for each method, the every element will be taken one by one in the iteration and forwarded as an argument to the accept method of the consumer and carry that input, the parameter directly to the parameter of the println method also. That's the understanding. Why we need to discuss about this? Because Java 8 has this feature. And moreover, this feature will be used predominantly when we go for streams. When we go for streams, then this will be, the method referencing operators will be used frequently. Any simple questions you have, please do let me know before we go for more understanding of this. No questions? Okay. We'll see more detailed demo. So I'll use the same package, or what we do is we'll create another package. Okay, it's okay. We'll have this. I'll create another class called method referencing demo. Okay, so if you watch here, the one thing that I'm going to do right now is I'm going to do everything customized. Okay, starting from your functional interface. So keenly monitor so that you can understand more in detail. The very first step is I'm going to create a custom functional interface of my own. I'm not going to use any general purpose functional interfaces. Rather, I'm going to use my own functional interface, which I'm going to customize it. So let's go ahead and create an interface. Interface, let's say car functionality. It's going to be more similar like a general purpose function interface. Okay, it is going to have two things. One is it's going to have an input type. Another one is it's going to have a return. Can you give an example for this style of functional interface? So let's say I'm going to have a method called public. The return is R, and the method is get. It'll consume, and then it'll print also. I'm sorry, it'll return also. So I'm going to have T of type T or name, let's say. Can anyone figure out what could be the general purpose function interface that we can think of in this style? Very good. So functional interface we saw in the last class, right? Functional interface will carry what? Input, and it will also provide return. So instead of using iCar functionality, what I could have used?
Function.
Correct. General purpose function interface, because nothing much of a difference, right? But if in case you have some domain naming standards, you want to follow that, just like that, you don't want to use function in your project requirement, you have some standards to be maintained, or there are some reasons behind using a custom functional interface of this style, then probably you can go for it. Otherwise, you better go for the choice of function itself. Okay, don't cook up your own functional interface again. Don't ever do that. Okay, fine. So now, anyways, for demonstration purpose, I've done this. Now, what R refers, it can return anything. What T refers, it can accept any type. It can return any type and it can accept any type. It's a generic version, right? What is the most important thing? Is this a functional interface? Is the first question. Is this functional interface?
We have to annotate
yes.
with functional interface.
That is not mandate, right? As I said last week, it is optional, correct? Because you already have what in this single abstract method. When you have single abstract method, then there is no need for marking it explicitly. But if you mark it explicitly, what will happen is you will not be able to have one more abstract method.
One more abstract class.
Correct. Not class, it's method.
Sir, abstract method, sorry.
Yeah, you cannot have one more abstract method when you annotate it with functional interface. But here now also it is functional interface. But the thing is you can have one more abstract method and call it as a normal interface rather than functional interface. That is the difference. So it will force you to not have more than one functional interface if you explicitly use the annotation called at functional interface. That is the understanding. Now this makes uh, more professional, right? The code seems to be more official. You have an interface and the interface is functional interface, so that you are entitled to have only a single abstract method. You have been forced to do that. If in case you have one more functional interface, then it will yell at us. The compiler will keep on yelling at us, saying that, hey, listen, that you cannot have more than one abstract method. The reason is the interface is already denoted as a functional interface. Now, when I hover the cursor, the compiler is yelling at us saying that invalid at function interface annotation is not a functional interface. It clearly mentions that the style of code what you have written here doesn't look like a functional interface style of code. So you're not permitted to have an demarcation of at function interface. So I'll comment this. Now, why is this a functional interface? Now, will this be a functional interface? No.
No, sir. No.
Yeah.
Two.
Because you have two
Yeah.
abstract method. Correct? Hope this is very clear, right? So in any ways, if there are manipulation of code, like any interview you go for, if they are having some objective questions, or if they are throwing some objective questions, nowadays what happens, since we are more of remote, right? Remote interviewing. So I do this intentionally. I throw a snippet of codes on the chat box of the teams when I'm connected with the candidates. Okay, so that happens henceforth going forward. It's going to be different. The lifestyle is going to be different in corporate world. So they will try to excuse us in different ways, which like as I do to the candidate. So I'll throw a lot of code snippets and ask them to read the code snippets and understand and tell me what is their level of understanding on the snippet of code. So anyway, they might throw you. So you need to be very clear. Okay. At functional interface is absolutely optional. It's not mandate. Please make a note of it. If it is optional, okay, if it is optional, still you can go ahead and create an functional interface by carrying a single abstract method. But the advantage of a functional interface, what is the advantage? The advantage is by mistakenly also you cannot have more than one abstract method, because the moment you have more than one abstract method, the compiler will be forced to alert us saying that, hey, it's already been marked as functional interface. Please don't have more than one abstract method in it. Okay, that is the understanding. But can we have a default method here with a definition? Yes, of course. Can we have a static method here with a definition? Yes, of course. That's what we discussed as a basic introduction on last week, right? We'll discuss more in detail about that right now. Okay, so this is fine. These are all pretty clear, right? Now let's go ahead and see that I'm going to create another class called, let's say, car. Okay, I have a car class, and this car class is going to carry a public, sorry, car of a constructor. Okay, and no argumented constructor. No argumented constructor. Great. This is all about a constructor. Then probably we can have some other constructors as well, but right now I'm not doing it. So first thing is, we saw the method referencing by calling a method, right? We saw an example just now for method referencing using a method call through object. So object instance method referencing. It is called as an instance method referencing. A method which is called on top of an instance, so that it is called as an instance method referencing. Okay. The next one that we can think of is having let's say static method referencing. Okay, we can have something called static method referencing. So how do we go about creating a static method referencing? The approach is in such a way. So right now I'm not doing that anyways. So first thing is we just go ahead and create the iCar functionality, iCar functionality, and what I'm going to expect from here is let's say okay, let it be a string, comma string. Okay, now the car object equals, we are going to write param1 comma param2. I'm sorry, it's only param1 for in this case. Okay, the param1 is nothing but the string. Okay, then you can just have you can manipulate with that p1. So we can, okay, We can think of having the return is what I'm just temporarily I'm not giving any return. Okay, just for a demonstration purpose. Let's make this as void. No return. It's only like accept. Okay, so in that case, just a string p1. I have it's going to be an integer math dot, let's say okay, ceiling. Okay, so let's take it in this way. So ceiling of p1. Okay. Now, if you look at this, this is actually converting. Okay, it's just converting math dot seal of p1. It's just performing the operations of the math operation, but the seal method is something very important. So what is the return of this? Return of this is a double. Okay, it just returns a double. So the return, we are trying to think of having the return value as well from here. So this is returning a value, and we are trying to capture that value if in case required. Now you can store it in some value and you can print it, or you do whatever you want it. But the understanding here is the flow of the Lambda syntax looks like this. As I said, we don't need to provide a data type here, correct? Because we use uh, the type inference. Automatically, it is understood that it's going to be of a double. And of course, yes, the body of the Lambda is a one-liner of statement. That's understandable. Now, what I'm going to do with this is a different story. Whether I'm going to print it later or not, that's a different story. But if in case you want to bring this down to a minimized version, okay, you just want to bring it down to a minimized version, then what we can do, how this Lambda can be minimized. That's the question. Okay. Right now, it is of no use. We are not going to do anything with this math.seal because we are not going to visualize the output. That is understandable. Now, how we can reduce this is you forget about all these things. We can just think of having a math scope resolution operator. What is the method? Method is seal, right? Seal, correct? That's all. Your job is done. Automatically, the input what you're going to provide is also there, and that given input to that particular get method, because we are writing the Lambda implementation for whom? For the get method. It gets something and forwards it to the body of the method, which is a one-liner statement, to the parameter of the seal method. Automatically, it's going to happen. It's more similar like what we saw in the consumer. But what is the difference? What is the difference between this line and this line? Any difference? Are you able to see? See here? Just compare it. What is the difference? Here also we are using the double colon, and here also we are using the double colon, which is a method referencing operator. But the only difference is
class name.
Instance.
Correct. This is an instance. Correct. Yes, this is an instance, but here there's no instance. So what we learned in the previous demo is this is a instance method referencing. Correct. Instance method referencing, wherein here we are going to call it as what? Static method referencing. So you can refer that to a method using a method referencing operator, even if that method is of what type? Static type. So for static type, what is enough?
Class name is it.
Class name is enough. I'm not creating any instance. But here out is an instance. Out is an instance of whom?
System plus.
System class, no. It's an object of print writer.
Oh.
This print writer object is created inside the system class. Do anyone know that? System.out.println, out is not an object of system. Out is an object of print writer created inside a system, but out object itself is a static. That's why you're calling that object through what name?
System.
Class name. This much information is there, right? Yeah. So I used to ask this question also to the people. Most of the people go wrong. So what happens is in the system, okay, if you see, there will be an object of out. Just a sec. Let's search for out. I'm sorry, I've just given as print, right? It's print stream. Okay, so you can see that out here, right? Out is an object of whom? Print stream. This out object is what? Static. So how do you call this out object now? System dot out. Correct? System dot out. And in the print stream method is where you have the method called print and println. You see, print method is there. Then you have println methods. Okay. So never ever say out is an object of system. It's wrong. Out is an object of print stream created inside the class called system as a static object, so that system.out.println. That is the understanding. Okay. Anyways, out of the box discussion. So here it's all about the math. Math is the class and static method in it. Usually math class has all its static methods only, right? Static methods and static variables, the constants, pi, math.pi, and so on. So I'm just calling this is method referencing. As the name suggests, method referencing is only for methods, only for method calls. Don't think that you can call some static variable, instance variable. No, it is only for method calls. See, println, seal, floor, all these kind of methods. If it's an instance, you will call it with an instance. If it's a static, you will call it with the class name. So what are the two method referencing operator you saw now? Instance method referencing. Another one is static method referencing. Is this clear? But practically speaking, we are not going to see any output because I'm not going to print. And moreover, you can able to think of having the method referencing operator only when you think of having a one-liner of statement. Only when there's a one-liner of statement, you are able to manipulate that lambda, whatever lambda that we wrote here. This much of syntax of line is actually compressed to just a minimalistic line of code, right? So that's the power of method referencing operator. Moreover, it is applicable only in lambda. Okay, so let's park this aside for a while. Let me go for this R again. Okay, the next one, what I'm going to talk about, okay, T and R, right? T, comma, R. Okay, now what I'm going to discuss more in detail is the next method reference, the next type of reference operator. So here what I'm going to do is, again, I'm going to take this iCar functionality of, now it's going to be of a car. Object equals, I'm just going to return. Okay, it accepts a name and then it can return, or it can just think of having the return alone. Okay, so right now I'm not just returning, I'm accepting and I'm returning. In this case, you can see one demo. I'll just copy this so that you can use it for reference. Okay, so let me comment this for a while. So technically speaking, it's only for return, no input. So what this method does, the method will return. What is an example for this style of function interface? Can anyone figure out how you can think of this?
Consumer.
Consumer consumes, right?
Supplier.
Supplier will
Return.
return. Correct. So you can think of having this in the example of supplier, but still I'm not using supplier. In this case, we can actually use supplier, but I have created my own custom function interface. That's okay. Now, what we are going to do here is, I'm going to write the definition for this method. Okay, the method definition, the lambda method, lambda operator. Inside this open curly braces, you can just say new. Okay, I'm just returning what type? Return what type? Car type. Okay, I'm just saying it's just need to return car type. So we have already a car. Car with what constructor? No argumented constructor. So new car of. Correct. So we have to use what keyword here? Return. Do you all agree with this? Is this clear? So I'm defining a method. The method will return anything of type. Now I'm saying it's a car because generic type is car. So I'm returning a car object. It is only to return a car object, right? So I'm returning a car object. How we can minimize this line of code? Any idea? Any idea how we can minimize this line of code? No open and close curly braces, correct? In that case,
No
I
return
don't need
keyword.
no return keyword. Automatically, what is understood? There is a
Object
return
returning.
statement. How it will identify this? Based on
Reference.
the method. Based on the method signature. What is the method signature is with return. So it is understood. The auto intelligence says that this instance need to be automatically returned from this method. So is the line of code is reduced? Yes, of course. This we already saw, right? The earlier demos we saw. Can we further reduce this? Yes, that's when the method referencing operator comes in. Now what I'm going to do is just think of having the keyword of new
Scope
colon
resolution.
car. Yeah, we have to use the scope resolution operator. I'm sorry, car of new. Car scope resolution of new. You can think of this way. That's all. Now what it means, like how we used for static, how we used for instance method. Now this is not method, it is invoking the constructor. Okay, so this is called as constructor method referencing. Constructor method referencing. Is that clear? Simplified, right? The name of the class, scope resolution. What this new keyword does? What is the new keyword actually is going to do? It's going to call the new keyword will call the constructor of which class?
Car class.
Car class. Because without a constructor, you cannot create an instance, right? You can also have a no default constructor, but I've just explicitly written a no argumented constructor. But let's see what's going to happen. Okay, when I execute this, let's see what's going to happen. The understanding is it should invoke this no argumented constructor and print this no argument by the style of code, right? So let's right click, run Java application. We didn't call this, correct? The method have to be called object dot get. That's all. So that the method will get executed. See, no argumented constructor is invoked. You're getting it? Now, what I'm saying is this is one style. Okay, now the question is method referencing operator can be used even if you're just going to create some instance and return it. But what if in case if one argumented constructor, and inside this I'm going to say this dot name equals, right? And you can just have some method like public void print and this dot name. Okay. So now it's carrying both. Now I don't have this constructor of no argumented. Now the challenge comes. See what it is asking for. What this line is asking for. Hey, you cannot create an instance of car because the car needs parameter for its constructing. You have only constructor with parameter, but you are telling me to create an constructor without, telling me to create an instance without calling an parameterized constructor. That's how it looks like. So the same constructor method referencing, we can write it in the other way around. How, in sense, in this style of mechanism, then sure your get should have one parameter. Okay. In that case, car, comma, sorry, string. What is the first thing? Return. Okay. Car, comma, string. First one is return. Second one is type. Now the error is resolved. How it got resolved? Because there is an input for this lambda. Okay. Right. Automatically, what will happen here is this is a return and this is an input parameter. Automatically in this constructor method referencing, what will happen is the string whatever you're going to pass will be passed as an argument while the constructor is created. So how it's going to be? It's going to be return new car of whatever value that you're going to pass from this get method, that will be injected here. So let's say BMW. But this line of expansion is not there, right? You need to understand that this line of code is what is automatically implemented using this constructor method referencing. You're getting it? So automatically when the call of the constructor is going to happen, it's going to forward this string that you're going to give. So we'll just go ahead and pass the value. Okay. Now what this call will do, actually it also returns. So when it is returning, it's returning an object. So you can say dot, what is the method? Print. So print and see whether that OD is getting printed for that particular instance or not. The instance which you have created, that instance is what is written, and with that instance you are trying to print the value that's been imposed into the instance variable, that is OD. See, one argumented constructor is invoked and OD, but explicitly I'm not passing this. But how this line could have been written? The line could have been written this way. This particular constructor method referencing line would have been written this way, comma, string. Okay, it's S1 parameter and S1. Is this correct? This line of template is what I've written this way. If it's the other one that without a return keyword you want to use, of course you can use that as well, because it's a one-liner statement, right? So if it's a one-liner statement, then you can think of avoiding this. The only thing is string S1 and forward the S1. We need to do this explicitly, but now I'm not doing it here. Correct. That's the power of constructor method referencing. Is that clear? So how many types of method referencing we have seen so far? 3. Instance method referencing, static method referencing, constructor method referencing. So instead of writing this line of code, we further reduce to this line of code. Instead of writing this line of code, one liner, we have reduced further to this. Actually, this can be further reduced. How? Any idea? Any idea? Actually, this itself got reduced. Correct?
Remove
No
the-
argument.
No argument. Understood that it is going to take an argument here. But the problem here is, I'm sorry, it's not no argument, it's an argument, but the argument brace is not required. Correct? Why? Because there's only one.
parameter.
Yeah, one parameter. This we discussed in last week itself.
Yeah.
Okay, so this can be, but instead of even writing this line, we can further reduce it to this. Got it? See how we are evolving, starting from here to here to here to here to here. This is how you need to understand the concept so that you'll be very confident when in the interviews if they are trying to come up with more tricky questions or trying to create a confused environment for you to understand. You need not get confused. I'll just show you a slide. Okay. So this is the slide that I'm preparing, which I'll be sharing it. It's almost done. Almost done. Probably I'll be sharing this week. Yeah, method referencing. Okay. So what is this method referencing? Just look at this. I am not going more in detail. You can learn it. Okay. Because the idea of this training is only to give you more practical demos. So what it does, method referencing is an anonymous class can be replaced with what? Lambda expression. A lambda expression now can be replaced with what? Method referencing. That is the idea. Okay. So what are the types of method referencing we have? There are 4 types actually. Only 3 types we have seen. The first type that we saw was instance method referencing. Instance method referencing. This is what we did. Another one is static method referencing. This one we have seen like string dot value of, instead of this what we saw, math seal. Correct. You can also think of another static method like value of. This is instance method referencing. So you can just say yes dot toString, convert it to a string. Okay. Next one is constructor. Constructor method referencing. This is what we saw just now. Another one is arbitrary method referencing. Reference to an instance method of an arbitrary object of a particular type. Okay. So you can instead of using, like when you are using toString, right? This true toString can be called without even the instance. Directly you can call it with string. That is what is arbitrary use. Okay, no need of, it's more of like an instance, but you will use it like a class. Don't think that it's a static. No, it's not a static method. Instance method can be called with the class name. Instance method can be called with the class name directly if the type is directly. But then why you need not, why you didn't do it in the system? You can ask a question. Why you didn't do it in the system? Why I didn't do it in the system? It's because between the system and the print, what we have? There is an object. You're getting it? So that's the reason. Okay. Otherwise, there is also one option that what it does is when it is an arbitrary object, it internally takes the instance and then calls the instance method. It internally work around with the instance and calls the method. Okay. So it internally manipulates with the instance and then calls the instance method. So we need not cook up the instance. That is the understanding of arbitrary object. Probably when we go for streams, let's see if I could demonstrate this. Okay. So this is one example, string colon toString. So these are the four types of method referencing. This slide is more than enough. Almost 105 slides I've created. This 105 slides is more than sufficient for you while you're sitting in for an Java 8 interview. Okay, thoroughly it covers everything in detail. Okay, plus you carry the demos, whatever I'm showing in the sessions that you have to practice, and also you can go for additional practice. So yeah, method referencing, that's how it happens. So you can see is classic is a static. So I'm using method ref. Method ref is the class name. So class name is classic is a method. iMovie is a functional interface. Like how we created a get method for iCar implementation. The same way here, there is an example like iMovie, our own functional interface. You're getting it? So there is also another example that you can see, compare ages. Okay, you can compare the age between two objects. So we are using the compare ages. Compare ages is going to carry the method. So this colon compare ages. So this means what? It refers to the current instance. You can either say person compare ages, or you can just say this. Both means the same. But compare age is a instance method. Please note down, compare age is an instance method. You can call that instance method just by using the class name. That's the power of method referencing operator. That's the arbitrary method referencing. That's the example of arbitrary method referencing. Okay. So this we manually created this in order to compare two objects. I just created, and we are using the arbitrary method referencing operator. I've also created the function interface 43, 4 families, consumer, supplier, function, predicates. You have all the types, major types that's been listed here. You can just have a look at it. And I've also taken the docs for functional interface, each functional interface. Like if you look at the consumer, accept and then, okay. So for predicate, you have more methods, multiple default methods, static methods are there. Okay, so this is, but there is only one single abstract method for predicate. That's your test method. Okay, so this is just an example I've given for predicate and consumer. You can think of having it for supplier and function. Okay. So if you have any questions on this, please do let me know. We're already done with 1 hour of time. So these many things are there in the method referencing process. Method referencing is not just by using some 2 colon, that's all job is done. You have to think of the method referencing can be applied on object instance. Method referencing can be applied on the class name for static. Method referencing can be applied on the class name even if it is an instance method that is called as arbitrary, and you can apply it for instance. And you can apply it for constructor method call. Whenever you want to call a constructor in place of creating an instance, then you can call it as constructor method referencing. I've shown the demo with the argument and without the argument also. Right. Yeah. So any questions, please do let me know. This part is
Sir,
clear, right? Yeah, please go ahead.
yes, sir. We can say that so the method referencing that colon 2 colon operator is replacing the lambda.
Correct. Replacing the lambda syntax, but it is a lambda only. There's also a lambda, but
Yeah.
it is actually what to say. It's a you have something called sugared code and desugared code, right?
No, sir. I am not. I don't know.
Okay. This is your sugared code.
Okay.
At the runtime, it will be desugared.
No.
Means they will take it in terms of like this.
Yeah.
You're getting it?
Yeah. Yeah. Yes. Yes.
This is
So
only for our developers ease, they are making it. So
yeah,
this is a sugared code.
compiler will understand this is a
Correct. Correct.
replacement for lambda, so we can return what
Correct.
lambda does.
Correct. Correct.
Sir, and one more doubt, one more not related to this topic. As I told, the out is an object of print writer, right? And
Print. Yeah. Print stream. Sorry. Print stream. It is.
print stream. Sorry, it's a print stream object. Is the it comes from the base object class only, right, sir?
Base.
No, which is the base class for print stream? Like there will be hierarchy will be maintained, right, for everything. Which is the topmost class for this print stream?
No. Print stream. Print stream is see the topmost class is only object. Okay.
Object, yeah.
Anything
So
you go for topmost class is object. So if you go for like in is input stream, if it is a out means it's a print stream. So if you go for print stream, they might have something called file output stream because it's a print out process. It's I'm sorry, filter output stream. So if you go to the filter output stream, it has output stream. Go to the output stream. Further, it has some implementation of interfaces, but this is the end. This extends whom? This extends finally the topmost class called object.
yeah, that's what, sir. I want to understand that.
Yeah, if you see the flow goes like this. See, you can look at here, right? System, inside the system, we have created an object for print stream. So let's take print stream output stream object, but anyway, print stream's topmost hierarchy is object.
Yeah.
There is a meaning.
Yeah.
Is that clear?
Yes, sir. Okay.
Any other question? So it's not only in Java, right? Even in C#, if you go for the topmost classes object. That stays common across any scenarios you go for. But yeah, memorizing this, I'm not sure. This is like literally little challenging only. I don't think this we need to memorize. So print stream is fine. Yes, print stream. So system class object is not out. Out is an object of print stream created inside the system class as a static, so that you are able to use system.out.println.
Yes, sir. Yes. No, sir. I just want to know since it is an assumption. I thought I believe that it will come from object class. So I just want to confirm.
Of course, yes. It is object class. Anything, even for system, the base class is object. Topmost class is object.
Yeah.
There's no extents. So who's the base class for system now? Object. Why system? Why we need to go for system? Let's take this example. I have created my own class car. Who's the base class for car? Object. Correct. Even though we haven't, see, no class in Java is the base. No class in Java is the topmost base. The only class that is already topmost in the hierarchy is object class, which is already available in the java.lang package. Any class you think, even if this think like you created an employee class, you created a product class, and they don't have any inheritance. Even if they don't seem to have any inheritance, like extends, still it is extending, and that's your object. That's the understanding.
Yes.
Okay. Any other question for this method referencing? Do anyone? So please recall that instance, static, constructor, and arbitrary. What are these? Types of method reference.
Referencing.
Correct. Types of method reference. So how many method referencing types are there? I used to ask the question. People will say one, and that is colon. That's all they will give as an answer. Because that's how they've been worked on, right? But actually there are 4 types. Styles are instance, static, constructor, arbitrary. Okay. I guess we can move forward because we are running out of time. Okay, now before I take you to the streams, okay, I'll create another package. 2.day1.demo. The most important topic, interfaces, because that has a many differences, changes in Java 8. So interface in Java is completely changed. So far till Java 7, we were saying it as what? Pure abstract. Correct? Interfaces are purely abstract. But how about abstract class? Any idea?
It has static and non-static methods.
No,
It
it
has
is like
both
abstract
abstract and non-abstract.
non-abstract methods, concrete methods. So it is partially abstract, correct?
Yeah.
Why I'm saying partially abstract? Still you can have what? Non-abstract methods there. Concrete methods you can have. But in interfaces, you can only have what? Abstract methods, 100% abstract methods. That's how till Java 7, correct? And you cannot create an instance for abstract class. You can. Yeah, I'm not sure whether you're watching my code snippets every day I'm posting, right? Please go through that, okay? You will recall your earlier learnings, okay? So because we tend to forget things, right? So by looking at these kind of code snippets, we can recall what we studied in our language. So that's the reason I'm posting it in every possible ways. So please do go through that. You can recall. I'm also integrating Java 8 things. Today also I posted relevant to default method. I'm not sure how many of them have watched. I've used a method called default. Just spend some 10 minutes of time on looking at those code snippets. We might be having hundreds of work. That's IS, of course, but still we have to work in recalling what we have studied. Okay, so otherwise we'll forget. A very interesting questions actually today I posted, and it's a little complex also. Seems to be pretty easy, but actually a lot of insights are there inside that particular code snippet. Today's and yesterday's code snippet also a little tricky. More learning over there. Okay, so not creating instance. You cannot create instance in abstract class, and in interface also you cannot create instance, correct? Rule stays same. In Java 8, you cannot create instance for abstract class and you cannot create instance for interface. That rule stays intact. But what happened in Java 8 is abstract class, there is no change. As it is same as like other version, abstract class. But the change brought in only in the interface. In interface, they have started to accept not only abstract method, you can also have non-abstract method. But non-abstract method will be seen in the style of default method and static methods. Default method and static method. Are you getting it? So now the question comes, what is the difference between an abstract versus interface? Abstract method, non-abstract method, correct? You cannot create an instance. Is not possible. And here also you cannot create an instance. Creating an instance is not possible. Correct? Now anyone tell me what is the difference? If every rule stays same, what is the difference? Can I use abstract class in place of interface? Or can I use interface in place of abstract class? Can I think of in that way? Anyone? This is one of the questions that I used to ask in the interview panels. I'm talking about interviews in between. Okay, don't think I'm just focusing on interviews, but ultimately that's the end, right? First thing is we need to clear the shot of interviews. So anyways, learning is also there, but I'm just saying we need to be very much prepared for interviews. Anyone? Interchangeably, can we use them? Any idea? Anything that runs in your mind, probably you can throw.
Multiple inheritance not possible, I think, in abstract class.
Multiple inheritance. Okay. Multiple inheritance you cannot do in abstract class. In interface, we can do multiple extents. Okay. Multiple extents of other interfaces can be done. Okay, good. But anyways, ultimately, there's going to be again no much difference, because finally what is going to happen is we are going to think only in the style of class. The class is going to extend abstract class, and the class is going to implement interface, the final interface. Even though this interface is going to use I1 and I2, but finally we are going to use only I in our class, correct? But anyways, that's a good difference, yes. But can I replace interchangeable, because it seems to be more reasonable of all the definitions? Of course not. The first thing that you have to always think of is this one. Okay, how you need to understand the abstract class and interface is like this. Abstract class. So I always give this example. Starting from my initial career, I take this as an example. I'm not sure people who have attended my training in earlier institute, probably you can recall. We have class called animal. Okay, we have class called uh, bird. Okay, right, and we have a class called mammal. I'm just bringing this mammal as a root. So I do have a class called human. Is all these class are related to each other? Seems to be like related to each other. Human, bird, animal. Yes or no? All the three classes are related to each other or not? Related to each other means, is there any relationship that we can think of? Yes, of course. So animal extends mammal. Bird extends mammal, even though we don't directly say it's mammal type, because mammal type variants are there, but the root is mammal. That's how we need to understand. Even humans extends mammal style. Then what mammal is? Mammal is your base class. So we can mark the mammal as what? Abstract, correct? Abstract classes are meant for what? The base class in the hierarchy. Is this correct flow? Perfect. So abstract class is used to bring inheritance relation, logical inheritance relation. Okay, logically related relationship. Logically related relationship is what you can achieve through this abstract class. But that's not the case when it comes to interface. Interface is still interface only. You cannot think of replacing abstract class with interface. Why? So let's say I have interface called airplane. I have an interface called bird. I have an interface called Superman. And I have an interface called what? Airplane, bird, Superman. Okay, whatever. Just think of having these three. I have an interface called flyer. What is the common between these three?
Fly.
All three can fly, correct?
Fly.
Even Superman can fly. So what does airplane have to do? Implements, correct? Whom to be implemented?
Flyer.
Flyer. And inside that interface flyer, there is one abstract method called
Extend.
fly. No, it's not extends, right? This is implement. Interface means implements. Abstract class is extends. Bird implements flyer. Superman implements flyer. Now all the three interfaces, I'm sorry, yeah, this is just for reading, I'm sorry. Yeah, you are correct. It's extends, but I mistakenly used this interface. Okay, sorry, you're correct. Think of this is not interface. Okay, this is a class. All these are class, like how we had animal, human and bird. The same way here, these are classes. Is my voice is clear? I have some bad network.
Yeah, yes.
Okay. I don't know why I'm getting this. So let me check my network is correct. We have full signal. Okay. So now, yeah, so these are classes. Okay. So class to interface, it is implements, right? If it is interface to interface, it is extends. Yeah, what you said is correct. I'm sorry for that. So it is implements. Now it is a class. Now the thing is, the fly method will be overridden, right? In each and every class, the fly method will be overridden, correct? But how the bird will fly? Using some feathers and take off and something like that. Airplane will also do that, but they have something called additionally engine and turbine or something like that. Superman is supernatural, so obviously it is different. They have some flying suit or something like that. So, but they all can fly, but how do they fly is implemented only in that overriding method of that fly, correct? Now the question is, are they related to each other? Airplane is bird and Superman are related to each other. Like how we say animal, human, and bird, correct?
Yes. No, they
Are
are not
they
related to each.
related to each other? They are not. Bird is a living being, correct?
Yes.
But airplane is a non-living thing. Superman is a what to say, a supernatural thing, and it is not real, unrealistic character, right? It is at least airplane is visibly, it is more physically available, but Superman is only imaginative thing, right? They all three are unrelated. Unrelated classes will use the interface only for what purpose? Unrelated classes can use the interface for what purpose?
Common function.
Very good. It's only for using the common functionality. That's all. Dot. But they themselves will not have interrelationship like how we had with the abstract class. So still there's a difference between abstract class and interface, correct? You agree with that, right? Still that difference stays intact, even though interface I've started accepting non-abstract method, similar like abstract class. Interface can't become an abstract class. Abstract class will enforce an inheritance relationship, but interface will enforce an implementation relationship. But this is not an inheritance strategy. Inheritance strategy comes only through the class and abstract classes, not with interfaces. That difference always stays intact, no change in that. And you enforce a policy through interface. Through interface, you are enforcing a policy, okay, for implementation purpose. That's all. Okay. So still the difference stays intact. That's what which I wanted to conclude here. So interfaces and abstract class can't be replaced to each other, even though they have the abstract method. Please throw that in. Abstract class uh, is the type used for better
Logical
inheritance strategies. If you have any questions, please let me know. Okay, so now let's go for one by one. I'm going to create one interface. Okay, the first interface called, let's say, audio player. Okay, I've created as a class. That's fine. Uh, so I have an interface called audio player. Okay. Then inside this, I'm going to create class called audio thar. Then okay, so I have three car classes. You can see Audi, BMW, and Thar. Now all the classes is going to implement Whom? I audio player. Correct? That's what which my use case says. So BMW, Thar, okay. Now, if you look at this I audio player, I'm going to have a method, an abstract method called public void play audio functionality. Now, what these classes have to do, the three classes, all the three classes should be forcibly,
Play audio.
yeah, it has to be forced to override the play audio. That's reasonable, right? All the three classes are using that interfaces and they have to override the method. Perfect. Understood. Great. Yeah. So here in the audio, I'm sorry, in the Audi, BMW and Thar, all three have the overridden method, the play audio. Now, what if in case if they come up with something called like this public void touch system? They add some new feature called touch system. Now, what happens? Is all the three classes are impacted?
No.
Yes.
Yes. Since we add one abstract method, as per the rule, when an abstract class is when an interface is implemented inside another class, it has to override all the abstract methods, correct?
Yes.
So just by adding one, three. But what if in case I have 3,000 classes in my biggest application? And in the 3,000 classes, I have somewhere 275 classes is depending on this interface. And suddenly when the interface is upgraded, they are coming up with a new feature called touch system. Now I need to override in all the 275 classes. Do I need to do that or not?
No.
Of course, yes, because all the 275 classes are implementing this interface. So it is mandated to override them. But unfortunately, Tar is coming and saying, hey, I have a mid segment of business. So I cannot afford by adding a touch system and increase my price for my customers. And customers are not needed for that. So in my Tar category, I don't need that. So why do you force me to do this? I don't want. Don't impact my application. Audi is a higher category car. BMW is fine. So luxury category, so they can have and afford it. The customers can afford. So this they cannot, but still they are forcing. So I audio player is an interface provided by a third party application. Okay, when the third party is coming up with this, it is forcing all their clients, okay, customers. I audio player vendor is forcing all their customers to use their touch system. But Tar is saying, no, I don't want. Why do you force me to do that? So in that case, what I can think of is, can I think of having this with some default implementation like this? An empty implementation so that it's nothing there. If needed, let them override it and do it. Otherwise, not required. But the problem is interface can't have what methods?
Concrete method.
Correct. Cannot hold concrete method. Cannot hold concrete method. But we can when you prefix it with the default keyword, automatically it is acceptable. Now if I save, see, all the compiler error is resolved just by adding this default instead of abstract. Now what this scenario says is, this third party vendor is offering a new feature, and that new feature can be overridden according to your need, or else you just leave it just like that. Okay, you just leave it just like that. You don't need to do anything. You don't need to override them. I'm not forcing you. But if you want to override, you just override it and add some features and use my features or whatever, you can do that. But the thing is, the 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 explicit forcing is not happening, or the backward compatibility issue is resolved just by adding a new thing. Existing application is not disturbed just by adding this default. But if you want to give some predefined, so let's say I'm giving it free of cost. I'm giving this free of cost, and it's going to be common across all the car systems. Now what I can do, I don't want them to override them and do the implementation. I myself will provide it. So I'm going to give some piece of code here. So let's say I have some 10 lines of code written to support this feature. It's a pre-written code, right? So they can just like that use that. Correct? So see how many advantages that you get out of having this default. So backward compatibility issues can be resolved. You can override the default method, or you can just like that use it without overriding, because this method is inheritable. Inheritable into which classes? The class which is implementing this interface. Automatically it is inheritable. So let's see this demo. So here I'm just going to say this is a free touch system. Okay, so now we can go to the app. Create an object. Tar dot what method? Touch system. Just like that you can invoke. See, it's still available. But tar seems to be classes only overriding whom? It is overriding only play audio. Correct? But how about that method is coming again suddenly, the touch system, because it is coming from the interface which is declared as a default, and it is automatically inherited into the respective implementation classes. So if I run that, you will only get the default thing that is already provided by that vendor, which is nothing but this is a free touch system feature. But if you wanted to invoke tar.play, then the tar's play audio is what is executed. The play audio, tar play audio. Like which you can do it for the Audi and BMW, but they are not impacted. And one more thing is, in the interface, they have started to accept static methods. Why static method? Static method, so let's say I have a static method. Okay. Instead of default, you can have both default and static method. So let's static method, let's say HD display. Okay. So this is going to be marked as static. And say this is a free HD display. Okay. Now you can have both default and static methods with definition in Java 8 onwards. From Java 8 onwards, you are entitled to have default and static methods with definition in your interface. Is that clear? But what is the purpose of static method? Let's go and see. In the app, if I say tar dot, what is the method name? HD display. I'm not getting that. You won't get it because static methods are not inheritable here. The need of static method is to call from the class name or the interface name, right? It's not inheritable, neither inheritable nor overridable. You cannot override them. You cannot override the static methods, and you cannot Think of inheriting. Then how to access them? What these tar and thing can do is they can use directly audio player, the name of the interface dot htDisplay. It's like a plugin. So it is used as what methods? Utility methods. You can use them as an utility methods. Okay. The static methods and interfaces are entitled to be used like an utility methods for your existing applications or for new existing applications. In order to resolve some backward issues, it's better to have the static methods. But default method, it's overridable and it's inheritable, and you will access those default method only through the reference or the instance of that particular class. You can see that. But here directly from the class interface name itself, you can call the static method. That is the advantage of having a static method inside an interface starting from Java 8. Is that clear?
For backward compatibility, exact terminology meaning I am not getting, sir. Backward compatibility.
Compatibility is, see, backward compatibility is, I have already written one application, okay, using Java 7. Now you are migrating that application to what version?
8
Java
or
8,
11.
Java 11 or Java 8, anything after from 8 or 11 or whatever. When you are migrating to Java 8, okay, Java 8 in there suddenly there is one method in the uh, in your interface. You have one abstract method. Correct. In the API of Java 8, there is one abstract method. When you're migrating, when you're using that particular interface in your existing Java 7, will it force you to override or not?
Yeah, yes.
But instead of having that defined as an abstract method, you can define it already in a default method. So when you migrate from Java 7 to Java 8, still your backward compatibility problems are not there. When the 7 to 8 migration is backward compatibility. Java 8 should support backward version of your application. It should not suddenly say you dismantle your entire Java 7 application, rewrite it from Java 8. Will you accept? I have some 3 lakh code base. Will I write all the three out of 3 lakh code base? Let's say some 50K, 50,000 lines are depending on that mechanism. So that 50,000 lines of code in Java 8, when you come, they are telling you to rewrite it. Will you rewrite? No. You should support. You should support even it's a obsolete, even if it's a earlier version of that code, you should be in a position to support. That's what backward compatibility support is. So Java 8, that too, they came up with Lambdas. So it's a major change. And Lambdas are all in the implementation of functional interfaces. A lot of change have happened. So in order to support that, your earlier versions of a code, they started to adopt these features like default methods and static methods. Is that clear?
Yeah, clear, sir. And one more thing, sir, some callback issue and callback compatibility like that, some terminology I heard recently. Callback like that, callback, that means any idea, sir? Callback means.
Callback?
I heard actually in JavaScript, callback issue will be reduced using that, like that. I heard some bad.
No, that is callback methods are different actually. Callback methods uh, are exclusively an anonymous methods. That is exclusively in JavaScript. But this and that cannot be compared. Okay, JavaScript they again use arrow tokens, line of statements. The callback methods can be rewritten using the arrow tokens of the Lambda style in JavaScript. But here it is not that. That is not the case. This interface implementation is something different. Nothing to talk about callback method support. This is only for the major support is for backward compatibility. And also
Actually, callback meaning I am asking, sir. Callback means.
A callback method is a method which calls another method in turn in the parameter. Okay. So let's say, for example, you have a submit. Okay. So when you click the submit button, okay, there will be a method for that submit button, and it is actually an event, right? So what is that event? Submit method, it's an event. So what is a event? Click is a method. When you call the click method, okay, when you call a click method, the click method will in turn call another method, and that's what is a callback method, a function. Okay, so let's say submit. So when one function calls another function internally in the sequentially for, it's a callback method, and the function is technically not named. Actually, it's not submit. It's an anonymous method. So in JavaScript, what you will have is you will have a method called X, and you will have the parameter inside that method will be like this. You're getting it? Parameter itself a function, but the function will be an anonymous function. That anonymous function is for what purpose? When you call the X will in turn call that anonymous function. So it is called as a callback. So when you're using jQuery, probably if you'd have worked on jQuery, you can understand that. You'll use dollar, right?
Understood.
Yeah, dollar dot, and then you'll use some functions, and that is exactly a callback implementations.
Selector.
So internally, a function calls an anonymous function. Okay, so that's what a callback means. It's an event based. Even in Java, we have callback methods. Okay, when you're using AWT abstract window toolkit. Okay, so that time the event based mechanisms is all callback methods only. Okay, but there it's like implemented through anonymous class. But here it is anonymous function in JavaScript. A function which calls another function without the function name. It need not call the function. Automatically it will call internally. That's what is callback methods are.
Okay, sir.
Yeah. Okay, so I guess we can take a break. It's already 6:40, so we'll take a break for 15 minutes. I'm sorry, 10 minutes, and then we'll come back. Hello. Am I audible?
Yes, sir.
Right. So is there any request? Okay. So yeah, do you have any questions on this? We have to discuss one more thing on the interface. So any questions, please do let me know. So please always ensure that henceforth interface can carry definition of methods which are considered to be a default method, which is non-abstract, and static methods, which is non-abstract. And it can also have variables. I hope you all knew that, right? Int x equals 10. Okay, automatically you can see it is italicized because this is static final variables, which are constants. You can only carry constants. That stays same, no difference. So any questions, please do let me know.
Sir, one question. So, in
Yeah.
app.java, so we overrided the default method. Okay. So default method implementations. That's it.
Yeah,
Tar
in
dot
the tar
system.
class, the default method is
We have the,
inherited.
yeah, we have overridden. Yeah. Okay. Sir, on app.java, we have implemented that. Correct. Sir.
Hmm.
Yeah, but like static methods, we are not done the same way, but we have used the class name dot that method name. So, but the return the default method and static method returns both returns the same, right, sir? So if you run that, so static method.
See, if you have to see this in a different approach. Okay, static methods, how you have to see is, let's say in this scenario, this candidate, this star and BMW and Audi is not having a provision to hold this method inside their class. They should not hold this method inside their class. Neither they should override nor they should hold this method. This method is automatically inherited, right? Default method is automatically inherited in the Audi BMW Thar when they implement this interface. Correct or not?
Yes, yes, sir,
Yes.
understood. Yeah.
But now these three people are saying, hey, no, I cannot hold any additional method. I'm okay with the play audio. But if you want to give something free, you give it. But I don't want to have it in my system. Let it be in the third party system itself. So I will access it. I will access it. So to access it, I will access your system itself. That's when the static comes in. So this method is not inheritable and this method is not overridable. If tar wants it, let them use directly their system iAudio player and call the method directly and use the functionality. But their
So
functionality should never be there inside their class. So this method is not there inside their class. Correct.
so we can understand that. Like Audi, BMW, Thar, it's not mandated to use the static. It's an optional for them. So
Default is inheritable,
yes,
but
okay.
optional from overriding. Default is inheritable, optional from overriding. But static method, when they implement, it's not like optional. They cannot use that method inside their class, inside their respective class. They cannot. It's not inheritable, non-inheritable, and non-overridable. Only when you inherit, it's overriding, right? Overriding concept comes only after inheritance. You're stopped from inheritance itself. You're not inheritable to this method. Okay. So when it is not inheritable, then how they can use? They can use it through this through their running system, like app method they might have in their system. In that app, they can use the name of that third-party interface and call the method directly. Nowhere they will inherit or nowhere they will override this method. So that's why I told you when I keep that instance tar, you should have noticed that when I keep the tar is tar class object, right? Tar dot, you will never see that method. HD display is not coming here. Why
Yes,
that
yes.
HD display is not coming? See, this touch system, they are referring it as a D, flagged as D. D means what? It's a default method. It's inherited. That's why it is visible. But that HD display is not inheritable. It's not listed in their TAR class or Audi class or a BMW class. No, it won't. If they wanted in there, they just use the third-party interface directly and call the method. That's all. So that's
Yes,
the need for static methods. So still there is a difference between default and static.
yes, my system got stuck when this
Yeah,
app.java
that's fine.
is
That's fine.
created.
That's
I didn't understand.
yeah.
So
That is the
what is that? I understood that audit.java, tar.java, BMW. So it is overriding that interface. So app.java is a separate class which is not related to this three class which is implementing that interface, right, sir?
yes, of course, yes. It is a separate class, right? But they might use this app in their system. App is a running entry, main method.
Mm.
Okay, I just want to run the whole application, then I'll use this app main. That's all, to create the TAR instance or BMW instance and then use it.
Mm.
This is only a small analogy, not the complete application, right?
Yes, sir.
So
Understood.
just for understanding, I've just created Audi, TAR, and BMW. But respectively, they will have their own projects. Audi will have their projects. Mahindra will have their projects, and all the three clients will use the same vendor, iAudio player. So this will be a separate API, right? This person will deliver it as a separate API. And in that API, they kept one interface, and that interface, they have a play audio, which will be consumed by all the three clients. But additionally, they come and say, touch system, I'm providing it. If wanted, you override it and do it. Otherwise, it's optional. I'm giving static method. You need not, it will not get inherited in your classes. You need not override it. If needed, you use my system interface name and call the method when you want to utilize the feature like this.
Yes, sir. Got it, sir.
Yeah. Do anyone have any other question? Okay. Now, one more thing that we have to understand here is what if in case there is one more interface is introduced? For that, what I can do is I can just go for one class called, let's say, fruit. It's a class and I have an interface. I1. I2. So there are two interfaces. Okay. Now, if you look at the I1, there is a method public void shape. This is an abstract method. Okay. In I2, there is a method called public void color. Okay. Now, this particular fruit class is going to implements I1, I2. What is the problem? What is the problem now? All the methods need to be over, correct? So color class coming from I1 or shape coming from I2. Is that mandatory to override? Yes, because both the methods are what methods in their respective interfaces? Abstract, correct? Now I'm going to introduce one more method, I1, called public void taste. Okay. Just an abstract method. The same method is also there in the I2 interface. Okay. So in the I2 also there is going to be the same method. Is the method names are same in both the interface?
Yes.
Now, what is the problem? You need to override. Whom you will override, I1 or I2? Both has the same method. So I'm overriding one method here. The method that I'm overriding is taste. Will this problem solved? Will the problem will get solved? Actually, it's a diamond problem that we used to face in C++. Correct. Multiple inheritance problem. Multiple implementation. Both the interface carries the same method. Okay, both the interface carries the same method. Taste. But the problem is resolved. How? Because both are abstract there. Correct. No body. Commonly, this class for both the interface, they override it commonly and provide the body. Is the problem resolved? Diamond problem issue is resolved or not?
Yes.
Correct. It is resolved. This problem is resolved. But so that's why they went in through interfaces and no more multiple inheritance support in Java, but only multiple implementation is supported in Java. This is what we are talking about for ages. But suddenly they have started to define this default method. What will happen when you have a default method in two interfaces with the same name? Correct? You need to, is there any need for overriding default method? This just now we discussed. Default methods need not be overridden. It is optional. You can just like that use it, right? So in that case, I'm just saying here sysout suite, and here I'm saying sysout soar. Okay. So now it has a two different definition, right? Is the definition same or different in both the class? Different, but the method name is same. Now the problem in your fruit is if you're overridden, then it's not an issue. But it's optional. You need not override, right? If you don't override, now the error is coming. Before we never got an error for default method because you need not override them. It's optional. But now the error, what it says is, hey, there is a duplicate default method. Which one are you inheriting? Again, the diamond problem now comes. Like how we faced in C++ so far, the same which we avoided in Java is now started to pop up. The diamond problem starts coming in. How we resolved in C++? Diamond problem, the multiple inheritance problem. How do we resolve it? By using scope resolution operator, correct? Yeah. Like which we cannot use it here, but we have another approach to resolve this problem. It's pretty simple. Yes, of course, you can override it. Okay, you can override the method. That is one approach. But if you override, okay, if you just override, you will not get their functionality, right? If you override, it's your own functionality in fruit. I'm sorry, why the fruit comes? Taste. Now, if you override this, the problem is, okay, the problem is these two things you will not get. I'm combining both. Sweet will also be there, sour will also be there for this particular fruit. So I'm combining it. But when you call this, you won't get the output. So in the app, if I go and create an instance, new fruit of dot taste, what will be the taste? What will be the taste? There is no taste. It's tasteless, empty. Correct. See, nothing is printed. Nothing will be printed. It's only Tar's output. But specific to fruit, that sour or sweet is not printed because we have already overridden. When you are overridden, it's empty. Will you write sour and sweet here again? Then there is no point in going for implementing these. Correct. So in order to resolve that problem, you can use I1 dot super keyword dot taste, and then you can call I2 dot super keyword dot taste. So the one solution is yes, of course, you need to override. After overriding, if you want the specific interface call to the method, you can go like this: I1.super keyword, interface name, super keyword, then the method. By this way, the problem is resolved. Now, if I run it, for this particular fruit, it is both sweet and sour. See? If you don't want sweet, you avoid that. If you don't want sour, then you avoid that. It's up to you. But overriding is one of the solution to avoid the diamond problem. After overriding, if you want to invoke the specific interface, then you have to use the interface name dot super dot the conflict method name. Are you getting it? This is another interview set of questions I always used to ask, and many people used to ask this. How do you resolve the diamond problem since interface have started to accept what methods? Default method. This problem will not occur for static. Why? Tell me. There can be two static methods with the same name. This problem will not occur. Why?
Because we
Interface
can't
different.
override that.
It's not inheritable and it is not overridable. You need to call the static methods only through what name externally using the I1 and I2. So obviously that diamond problem is not there for static. Now you can understand the difference between default and static, correct?
Yes, sir. Yes.
Hmm.
Sir, if we did use I1.super.test, I2.super.test, then compiler doesn't know which one to consider. So that is the causing of the problem. Right?
No. Compiler doesn't means when you're not overriding. When you're not overriding, the compiler doesn't understand that which one to inherit, because you cannot have same method signature in two types of same method signature in the same class, right? Now the compiler, what it does is it picks taste from I1 and inherits. It picks taste from I2 and inherits, and saying, hey, there is two method with the same name. You can't have in a class. I cannot inherit both the method which is of same name, same signature.
No, sir.
So
Yeah. Just we can override it, but we can command I1 and I2. Then we can run the program. Then it
it will
won't.
not. Yeah, the problem is resolved. Yes, overriding is a solution for the default
Overriding
methods
is a solution to avoid the diamond problem, but it will not give the exact
output.
output.
Correct. If you want to extract the output, then the only option is after overriding, you have to use the I2.super, I1.super.
Yeah.
Otherwise, reusability, I mean, there is no reusability, right? What is the
Yes, sir.
purpose of going for this? The code reusability. That's what inheritance is, right?
Yeah.
This is only one line. What if in case I've written some 25 lines here? And here there is some 35 lines. Almost 60, 70 lines, I need to rewrite it again.
Yes.
But that you can avoid it by just calling with these two names, and the entire 75 lines of code will come and sit here. You got it?
Yes.
But still, the diamond problem, the first level of problem is resolved. How it is resolved? By overriding that method to a common one method, local to that class. After overriding it, you invoke the respective one which you wanted by using the super keyword. It's not like super.I1. Okay, people used to do this mistake. It's not super interface I1, super interface I2. It is I1 which is super interface and I2 which is super interface. So the flow is like interface name dot super. You know what super keyword is meant for in Java, right? Super class method can be called, super class constructor can be called. That's what super keywords are meant for. Same keyword is used here, but prefixing with what name? Interface name. Is this clear?
But that is not available in previous version of Java, right? That it is
Of
used
course,
only.
yes. Yeah, this approach is not available. This approach need not be available in because in previous version interface never had default. They had only abstract methods. It's
And
mandate. You have to override and define it. No one will provide the definition from the
and
interface.
it has only empty methods or
You can keep it empty or you can define it. It's up to you.
yeah.
Yes, correct. The problem comes only the reason that we go for the default.
Yeah. Yes.
Hmm. Do anyone have any other question? Actually, we'll keep this comment here. this diamond issue is resolved by overriding. Okay, so this is all about Java 8 interface. That's all you need to recall and remember, nothing much. Okay, but when you go for Java 11, as I stated in the last week connect session, you have private methods. Private methods are for local utility implementation. Private default methods, private methods, not default, private methods and private static methods. Anyways, that's Java 11's thing that you can, if needed, you can just go and do some research and understand. So additionally, interfaces can accept default methods, static methods, private methods, and private static methods. Okay. I guess we are still having less time, so probably I'll be extending this week. Connect session will be there. So I thought of completing this week. I don't want to rush through anyways. That's not my intention. So we'll take another day of time, the weekday. Okay, package week 2 dot day 1 dot demo 2, so let's say streams. We'll just go to the first level understanding of streams. Stream demo 1. So firstly, we need to understand what streams are, what is it is meant for. So we'll just go through that practically. See, the default methods I've given here. Okay, another demo is also another analogy, the same Audi, Ford, Nissan. You have some set of methods which you are newly adding. So I've given more a flight method is added, so that problem will come and the problem can be resolved. So what is the need for default methods is provided, what is the need for static methods is defined, and what is the solution of this default methods, what is the advantage. So as I said, it's for backward compatibility. Okay, the binary compatibility of the earlier version of the code can be safely landed in this by just using the default methods. Okay, in the interfaces additionally whenever you want it. Okay. Okay, so now we have to go for this. You know what collections are. Okay, I'm not going to take you through the collections. I've just given some briefing definitions on collections, but what we are going to do is streams. Okay, so the first thing that you have to notice here is the streams is having a new package. Okay, stream is having a new package called java.util, which is already there for collections. Added to it, there is one sub package they have created, and in that sub package, the name of the package is stream. Okay, so how do you remember the streams? The package name is java.util.stream. Please remember this, java.util.stream. So Java SC8 Stream API is designed to help you manage collections of data, that is objects that are member of the collection framework. Okay, it is used to manage collection of data. Manage, I again repeat, manage the collection of data, but it's not going to store the collection of data. Store the collection of data is achieved by whom? Storing the collection of data is achieved by whom? Which API?
Collections.
Collections API. Very good. Like list, set, hash, hash map, linked list or array list or whatever. Those people will store the data. But streams, when you think, it's not storing the data, but supporting your collections to manage the data, manipulate the data, manipulate the collection of data. Okay, you can manipulate the collection of data. So when they introduced stream, they kept what in mind is to use lambdas effectively in streams. To use lambdas effectively, plus to use method referencing effectively. So method referencing will replace lambda, right? So streams lines of code can be predominantly reduced. I'll just show you one logic. Okay, what it does actually. Okay, and then I'll come back to slides. Few slides I will take. For other slides you can do it as a self learning, because the main idea is to demonstrate more. I'll just show you this. Okay, that is Java 7. Okay, in Java 7, if you see, I'll just give you the background. Okay, so you can see that in Java 7, these are all the stream methods. Okay, there are multiple stream methods are there. We'll discuss that. In Java 7, what happens is we never had lambdas, right? So we have arrays.asList, and I'm creating the new dish objects. You can see there are dish objects. It's of domain. We have the dish name, calories, and then what type of the dish it is. Okay, some set of informations are there, and the object is created. Now you can create as many number of objects you wanted, and we are creating a list of dish objects. Now I'm creating low calories dish. From this list of object, I'm trying to set a condition that greater than 400 calories you just add it. Okay. If d dot get calories, actually it's a low calories, right? So I need to give it as less than. It is greater than. I'm sorry. It is a less than 400 means it is a low calorie dish. So all the low calorie dish will get added in a separate list object. And after this, the low calorie dish will be further compared for different reasons. So you'll be using some comparisons, right? You want to do a comparison check, and then you need to do some manipulation. In sense, you can still go for sorting them. That is, I have I have taken the low calorie dish, but after the low calorie dish, I want to compare the calories and sort it in the order: 100 calorie, 120 calorie, 130 calorie, 220. It's in the order. Okay. So you can do the comparison, integer dot compare between the two calories. So I write a compare method of the comparator, which is an anonymous class. And then you apply the sort for this low calorie dish by passing the comparator object. After that, again I create one more list for just fetching those low calorie names, menu names, the food names. The food names alone I want. I don't want that calorie details. These are the foods which are low calorie, which I want to display it in my menu. Okay, so I create one more low calorie dish list, and then you iterate this low calorie dishes with sorted, and then you iterate the for loop and then get the name and add it in another final list, temporary list, and the temporary list need to be used with a for loop and print them. So see how many lines of code that we have written for this, correct? But this is in Java 7, streams in Java 7, manually we do. But in streams in Java 8, only this much of code. Only this much. What is happening? What is happening here? If you see, whatever things that we have done before in the 7 is all done here. You have a menu, which is a list of all the dishes is there. 400 calorie, 800 calorie, okay, 600 calories. Everything is mixed up here. Okay, you have some 25 dishes and their respective calories are also there in that object. So menu is a dish object. You have a method called stream method on top of this list, on top of the collection. So stream is applied on top of the collection. Menu is a list object. On top of the menu, the stream is applied. When you apply the stream, it will stream out all the objects and provide it to the stream methods. Whatever you are seeing here is all stream methods. Okay, like filter. What you need to filter? Less than 500 calorie. That is the first job. That filtered set of data will be forwarded to the sorted method. Sorted, where you will do the comparison between the two calories. After sorting it completely, it will again pass it to the map. Map it to get the name of it. Okay, you don't want the object. From the object you transfer it. This is called as transformation. Map is used for transformation, transforming from one object to another object, from dish object to string, because I'm fetching only the get name. See what is used here. Scope resolution operator used. I'm sorry, a method referencing operator is used. Finally, I'm collecting using a collect method and collected to one list. And the list what is collected is written finally to the terminal operation. This is your terminal operation, the last operation in the stream. The terminal operation is getting that list, and here again, see, we are using the consumers with the method referencing operator system.out.println. How many lines of code we have written? Hardly 1, 2, 3, 4, 5, 6 lines. But if you look at the previous one, we have written many lines of code. 1, 2, it's almost 25, 30 lines of code we have written, probably. Or let's say 20 lines of code. Out of 20 lines of code, we have just brought it summarized to just 6 lines of code. Which one would you prefer now? You will prefer only streams in Java 8 henceforth, and that too the streams are all applied. All these are what syntax? Whatever you're seeing inside the stream methods, all these are stream methods: filter, sorted, map, collect, for each. For each is list. Other than that, the other things are all stream methods. So all these stream methods are carrying what inside it? Inside it, Lambda expressions, correct? So streams are acceptable in Java 8 with Lambda expressions, or you can replace that Lambda with what also? Method referencing. Now you can relate that why we studied method referencing, why we studied Lambda syntaxes. So is all practically seen when it comes to streams. Is this clear? Anyways, what is these methods? We'll discuss that. But just to give you this difference of Java 7, streams is all manual. We need to do it through anonymous classes. Comparator, compare, a lot of things. But see, it's just a matter of sorted. Sort. Comparator is nothing but sorting, right? Compare the dish based on their calories. So it will sort it in that order. Are you getting it?
Sir, inside stream filter, sorted, map, this is particularly introduced in Java 8, right, sir?
Correct.
And
correct. These all
logic
methods belonging to stream, and stream is introduced in Java 8. Yes.
Yeah, that filter, sorter, everything. So they have some implementations written on it, and that's the actual job of what the collection does. Like
Correct. So the filter is a method which is already defined in the streams API.
Okay.
And that method takes an parameter. What parameter will that take? What is that we are returning here? A Boolean. Correct?
Yes, sir. It will check for some condition.
It checks for Boolean type. Returns is what? Less than, true or false, right? So
Yes.
returns true or false means hopefully it should be a
this one, predicate.
predicate. Very good. Yes. Now you can see the usage of predicate here.
Yeah.
This is predicate. Okay.
But
This is
how it is applicable for all the this example we have less than 500 like that, but in real time we may get various scenarios, so it will be applied to all the real time scenarios.
yes, of course, all the real time. See, when you go for collections, 100% you will use collections in your project. That's damn sure. If you use collections, you think of using streams.
Yes, I will see that. Okay.
Okay, but you might not use filter at the time. You might not use filter. You might not use sorted. You will get all the objects, but only thing is you want to fetch what from the object? Only the name of that from that object. So you can go for straight away what? Map.
Okay. First, we need to understand the method inside the stream.
You need to understand those. Yeah, then only you can start using. Yes. There are multiple methods are there, but frequently used methods we will discuss. Other things probably you can learn it, right? So these are all some of the essential methods which I'm talking about. So that's what I listed. I was trying to show here. See, these many methods you have. How to get a stream object? These are the methods. How to do the operations like filter, map, map to int, conversion, flat map, sequence. There are different types of streams: parallel streams, sequential streams. So these are intermediate operations. There is something called terminal operations. Terminal operation is for each. Just now we saw minimum, maximum. So what you wanted to do here is, instead of getting the uh, dish names, you can get the calories itself, but collect it and then check for maximum calorie dish or minimum calorie dish. You want to print it. So in that case, max or min is a method. Max or min is what? Is a average mechanisms, right? Average mechanism. So that average mechanism is a terminal operation. So we need to understand this first. Anyways, this part, okay?
Okay, sir. Okay.
I'll come one by one. Okay, so this is streams. So what we have to understand here is stream source. That is the starting point. Who's the stream source? Who's the stream sources? Who's the source for the stream? It's a list. List is what? It's a collection, correct? So the source for stream is that menu, which is collection list of menus, the food menus, right? These are food menu object. So from that source, we are creating stream. How we created? Just now we saw the code menu dot to create a stream. You will call the method called stream. The stream method will return a stream object. And on that stream object, you can apply intermediate operations. Intermediate operations means an operation which will manipulate its work and forward it to another operation. And that operation will do a manipulation and forward it to another option. What is another operation? What is the example we saw? First, what is the intermediate operation we created? Filter. Next, what we created? Sorted. Next, what we created? Map. Next, what we created? Collect. Finally, what we created? For each.
For each.
Or terminal operation. Terminal operation is the last operation that you'll be having. Just a second. Am I audible? Hello? Hello?
Yes, sir. Little bit it is breaking, sir, in the middle.
Okay. Just a second. I guess I have some network issue. Am I audible now? Is that loud and clear?
No, yes, sir.
Yes, sir.
It clearer?
Yes.
Okay. Okay. So yeah, I was talking about this intermediate operations. Intermediate operation will never produce results, output. Please make a note of it. Intermediate operations won't generate final outputs. They will only collect and forward it to another operation, collect and forward it to another operation, intermediate operations. The final operation is the terminal operation, which will like aggregate, count, sum, for each, and so on. Okay. So what technically happens is the operation final result is only one result that will be coming only from the terminal operation, not from the intermediate operation. Okay. So stream source, create a stream, apply multiple operations, intermediate operations, and go for the terminal operations and produce it. That's all. Terminal operation is the one who will actually produce the final result, but not your intermediate operation. Does it make sense? But please make a note of it. What is the difference between collection and streams, which they will be asking as a question? Is my voice is clear? Please confirm, because
Yes, sir, it's
Yeah,
clear.
clear, sir, clear.
okay. Yeah, so see the difference. Collections versus stream. Okay. Collection is an in-memory data structure to hold values. Hold value means what just now I said. Collection will collect the data, store the data in the in-memory. Whereas Java stream is a data structure that will not store the data, but compute the data on demand. Whenever needed, you can compute that, like filter, sorting, mapping, generating the minimum value, maximum value. All these are computational operations which you can perform on streams with the help of collections. So collection and stream should go hand in hand, but stream by itself is not a storage area. Streams are not storage area. Collection is your storage area. Streams are applied on the collection storage area to manipulate the collection of data based on demand. Are you getting this?
Yes, sir.
So Java stream doesn't store data. Java streams, Java 8 streams doesn't store data. It operates on the source data. Who's your source data? Source data is always going to be your collections, or it can be your array, or it can be some sequential file characters, character array, something like that. It should be some collection of data. Okay, and produce a pipelined data. Pipelined, that's what operations that we have in the pipeline. What is the operations that we have in the pipeline? Streams pipeline, filter, sorting, mapping, and so on. And finally, the terminal operation is minimum, max, or for each. So pipeline the data that we can use and perform specific operations, such as we can create a stream from the list and filter it based on the condition. The most important point that you have to understand here is Java stream operations use functional interface. Java stream operations take what as a parameters? Functional interfaces as the parameter. What functional interfaces are there? Is going to be general purpose functional interfaces, predicate, consumer, supplier, function. This is what they are using it as a parameter, like filter method, map method, sorted method will all take functional interface as a parameter. That makes it very good fit for functional programming using Lambda expressions. So the real-time Lambda usage can be really experienced when you come to streams. Is that clear? I'm taking this theory because here we need some theoretical understanding. That's why a bit of. Any questions? So there are two types of streams are there. I'm not going more in deep to it, but you can just make a note of it. There is a difference between the streams. These are some of the examples that I've given. You can see there are a lot of methods coming in. See this example. This one example. Library is a collection object. You're creating a stream out of it. Object, stream object is created. On that stream object only, we are doing map, filter, finding a distinct, applying a limit of values, applying a map again, and then finally collecting it to a list. Get the surname from the library, so from the book name, author name, and then convert it to uppercase. The name should be converted to uppercase. A lot of manipulations. What are these operations are called as? In the streams, in the stream pipeline, what are these operations are called as?
Intermediate.
Very good, excellent. It's an intermediate operation. Actually, collect I've mentioned there as an intermediate. Actually, collect is a
Terminal operator.
terminal operation because that is the final outcome.
Yeah.
Okay. So there are multiple examples are there. You can just have this cheat sheet. This is called as a stream cheat sheet. You can use it. For quick, before you go for prepare an interview, just look at this cheat sheet and you will be okay. Just go ahead with the interview. So in that case, Java streams are coming in the hierarchy of this. Okay, you have multiple stream type classes have been created. Stream, long stream, in stream, double stream, base streams. Different types of streams are there. You have double consumers. I mean, in consumer, these are the consumer types. Like consumer is like function interface. They are using the function interface respectively. Okay, so that hierarchy is what is defined. But how do we obtain streams? There are different ways. You can get a list and then from the list you can create a stream, or you can create a stream dot off method and forward the list. It will create a stream object, stream of persons, or you can use arrays.stream method to create a stream class dot off method to create a stream, or list collection list object set object dot stream to create a stream. There are multiple ways to create streams. Okay, this is some example that has been defined here. Okay, imperative versus declarative style. I guess this you can learn it. It's more self-explanatory. I've given the difference. Old style, imperative. Old style is imperative. New style is declarative. Okay, so that is the difference. So declarative is more powerful. I've given multiple examples for imperative. Java 7 version and Java 8. That is our understanding. Before to Java 8 version and from Java 8 version. See how readable it is. Correct. So sequential versus parallel streams also I've given some example. Okay, I'm sorry, theoretical understanding. So sequential streams and parallel streams. So it depends on the threaded implementations. Sequential stream one by one. First it will do filter and then only it will go for sort. Hello.
Yes, sir.
Yeah.
Sir, I think got disrupted.
Yeah, I got disconnected. Today I'm having a bad network. I don't know. Usually it will be
Okay.
good, but fortunately today it's testing my nerves. Okay. Uh, yeah. So I guess you were able to listen to that lazy, right? This is what I was explaining. Which part I was explaining?
Actually, it is stuck for me. That last thing you are
Which
explaining.
slide? Which slide that was disconnected?
Uh,
No, you were writing on something, right? That's just like.
This one, no?
Declarative something.
This slide? Or
Sir, your screen is not visible. Only.
oh, okay, okay. Sorry. Is that visible?
Ah, yes, sir. Now it's
yes,
visible.
sir. This slide only. Uh,
This
No,
is the
below.
last slide.
Cheat sheet.
Cheat sheet. Okay, okay. So this I was talking about the hierarchy of streams usage. Okay. So, anyways, I'm not sure whether it's still recorded on that. If the recorded will be there, anyways. This slide talks about how what are the ways to create streams through arrays, list.stream, or you can create through stream class. There is a special method called off method and forward the list. It will help you to create a streams, or you can use arrays.stream and then forward your array of object. It will create a stream out of it. So you can create a stream from any list of objects is what I was trying to explain. These are some of the example. I was talking about imperative and declarative. Imperative means old style. Declarative means new style. What is new style? Is Java 8. This is Java 8. I'm audible, right?
Yes, sir.
Yes, sir. Yes, sir.
So anything that you see before Java 8, okay, version, then it is called as what? Imperative style of streams. From Java 8, it becomes declarative. Okay. So I've given some couple of examples. You can go through that later. This is again a imperative and declarative style. I was talking about sequential and parallel. Default, the streams are sequential. Default streams are sequential. Sequential means I was talking about filter, map, sort, one after the other. After filter only it will go for map. After map only it will go for sort. But parallel, everything will happen parallelly. Why parallel stream? To make your operation much faster. But we cannot guarantee on the order of output. Order of output will vary because it is parallel. But sequential, you can maintain the order of order. You can guarantee for the order, but it will be little slow because it has to go step by step process. It depends on the use case. You can go for sequential or parallel, but the default is sequential streams. Please make a note of it. Default is sequential streams. Please confirm I'm audible, right?
Yes, sir.
Yeah. Okay. So yeah, so that is what it is. That is and also streams are lazy. Okay, it's lazy so that it's lazily evaluated. So stream lazy evaluations will go like this. All the intermediate operations, and then it will go for the terminal operation. If it's going to be lazy, streams are going to be a lazy, then all the operations will be manipulated when the terminal operation comes into the picture. Okay, perform your iterations. The iterations is done in terms of the last terminal operations because it's going to be lazily evaluated. Stream lazy evaluation. Each intermediate operation creates a new stream but does not iterate elements and performs operation until the terminal operation is invoked. Until the terminal operation is invoked, these each intermediate operations will not iterate the elements because it is kept as a lazy evaluation. Okay. Anyways, those are a little technical in terms of streams, but I just wanted to give you those, and these are the stream methods. Okay. Now let's go to the code straight. This is only a initial demo. In the weekday, we are going to have one more session, either Wednesday or Thursday. Probably I'll take it up on Wednesday. Let's see. We'll continue again on streams. So here I can just go for arrays dot as list. I can give a double value, let's say 3.45, comma 4.56, comma 7.65. Okay, these are double values. This will generate what? List of double. So I have a list. I got a list. So from this list, we can create a stream. From this list, we can create a stream. Okay. Hope I'm still audible to everyone.
Yes, sir.
But double values is a list. I want to generate a stream. I want to create a stream. So how to create a stream? Dot stream. There are two types of stream I told you, right? One is parallel stream. Another one is stream. Stream is default to sequential stream. This is your sequential stream. If you want to create parallel stream, you have to use parallel stream. But right now it's sequential stream. Okay. Sequential stream dot filter. What is a parameter for filter?
Predicate.
Predicate. Predicate is a functional interface. So filter you can provide the input value, which is this double value. So I can say value should be greater than of 3. Okay, so that's what we are trying to provide here. So the value should be greater than of 3. So I can have 2.37, 4.89, and so on. Okay. So dot map in the map we are going to use again an input. So filtered value will come in here, right? So that value should be mapped out as math dot seal to the value. Okay, then dot collect collector there is a class called collectors. Okay, I'm using that class collectors dot no, this is collectors, right? So we can directly go for collectors dot to list, converting it to a list. All the values should be converted to a list. Then that's all. This will return a list. From that list, you can go for each. For each is taking a consumer, and in the consumer, we are going to use 1 by 1 of value system dot out dot println of value. Okay, that is what we do. So this is how the streams will be. Okay, but if you see here, it's going lengthy, so we can use the formatting option. Okay, so that it will get formatted. So we can, it is not formatted properly. See how neatly it got formatted. Okay, we have the formatting option that need to be activated in IDE. There are some set of steps you need to follow to format it. Before it was one liner of statement, right? This is how we had. So you just say Control Shift F. That's all. In Mac operating system, it's Command Shift F. So neatly formatted. It's more readable, right? Streams are more readable. Now let's see what the output is going to be. 4.5, 5.5, 8.5. What is that 8.5 is? 7.65, how it got converted to 8.0?
Math.seal.
Math.seal. Seal means upper. Floor means lower. 7.6, right? 6. So it is rounded up to what? 8.
8.
Yeah. Why it is not considering 2.37 to 2? And why this 0.45 is not considered here?
It is less than
No,
5.
it is considered 3.45. We had 4, right? 2.56 is there. That is 5. 4.89 is 5 and 7.65. Yeah, this is not sealed actually. It's 4. It is down to it is unable to seal it because it's 4, 5. So it is 3. Why these two are not included? Because the condition filter says what? Greater than
3.
greater than 3.
2. 3, 7 is rejected.
Yeah, greater than 3 is included, but seal is not happening. Okay, so in that case, it is only picking 4.56, 7.65, and 4.89. Filter is applied, map is applied, collect to the list, and the list is iterated finally. If you don't want to iterate this, what you can do? I don't want to iterate. That's all. You just terminate it here. What do you have to do? You need to store it in one
List.
Very good. Because it generates a list. New double list. Now, which one would you prefer? Java 7 style of streams, or would you prefer the Java 8 style of streams? Obviously, we will prefer Java 8 because it eases up the developer's job. Plus, it has a lot of other advantages as well. Performance-wise, yes, of course, streams are a little better performance oriented, but you can opt for the streams or parallel streams. Sequential streams or for the parallel streams. It's up to you. But I can further reduce the lines of code, correct? How do I reduce the lines of code? That's when the hello.
Hello.
Yes, sir.
Yeah. Yeah, I lost actually. Okay. Yeah, so I was talking about this can be, you were able to listen to this, right? This part? Is this clear?
Yes.
I removed the for each and I collected in another list and I printed that list. Okay. This is what we stopped actually at last. What I'm trying to do is I'm trying to reduce the lines of code. Okay. I'm trying to reduce the lines of code. How? See how neatly it is formatting. Okay. So you need to use formatter for streams effectively. So this can be value. This is okay. This is a condition. That's fine. But this can be reduced, right? How we can reduce it? Math.
Method referencing.
Method reference operator. You can call the seal method. That's all. See now how the power of method referencing operator comes into the picture. If in case you are using the for each, okay, then for each can be further reduced, right? How to reduce the for each?
Sys.out.print.
What is the problem here?
Method with reference. Method reference.
Okay, this is list. Yeah. This one is not required. So here, in order to reduce these lines of code, we can simplify this, right? Just say system.out method referencing operator. What is the method name? Println. Now compare these two streams. Which one would you prefer now? First version or the second version? Obviously, we'll go for the second version because it's more simplified. This is with method referencing operator. This is also with, but this is what method referencing? Static method referencing. This is instance method referencing. Very good. Is that clear? If you have any questions on this, we'll see. I'll stop here. So weekday we'll have another session and we'll complete.
Sir, here map will do the operation on the variable, sir. Map. What is the purpose of map?
Map will operate on top of the element that is coming from the filter.
Okay.
3.89, 4.56, 7.8, right? In this, it is filtering. It checks 3.89. Is that greater than 3? If in that case, then probably it will pick it and give it to map. Map will operate this on top of this 3.89. It will seal it and then forward it. You're getting it? And that forwarded value, the rounded up value, let's say 4. Rounded up value 4.0 will be collected by collectors into one list. They will keep adding it here. 4.0. Next again, the next filter will do, map will do, collect will collect. Another one is 5. Like which all the values will be collected and handed over to the next. Who's the terminal operation here?
For each.
For each. It will come here and apply. So map will operate on top of the elements that is coming from the source. Who's the source? Stream. So source for the stream is a collection. Okay. So the advantage is you can use the streams line of code using dot operator like this. Instead of getting one object and object dot map and object dot collect, you can directly use dot operators and keep using them. Is this clear? So always do I need to start with filter? No. No filter at all. You directly go for map. Collect it for each. Okay. So filter map is your terminal operation. I'm sorry, filter map is your intermediate operation. Collect is your terminal operation. That's all. Your streams is over here itself. What you're using as a for each right now is on top of that list object. You're getting it? It collected to a list. That's all. Its job is over. This for each is on top of this list. That's all. If in case you don't want to collect it, you can directly apply the for each after the map. It won't collect in list. Instead, it will print it. Whatever the map seals out, it will be printing it. Am I audible? Hello?
Yes, sir.
Yes, sir.
Network is daunting me today. Okay. I guess I can stop here. So any further questions I'll be able to take.
Sir, if I want to use min or max
Your voice is not audible. Sorry.
one second, sir. Is it audible now, sir?
Yeah, you're audible. Please go ahead.
So if I want to use min or max method, can I use it after collect, or will there be a specific order that I have to?
No. Yeah,
Okay.
see, only one terminal operation you will be able to use. After terminal operation, there's no point in using another terminal operation.
Okay.
Okay, terminal operation is the last. That's all.
Okay.
After that, with the value, you can do something like here, collect list, and then you're doing just for each, right?
Yeah, right.
So terminal operation is the last minimum value you're trying to find out. That's all.
Okay.
That's a single value. After minimum, you can't find the max, right? See, minimum value is lesser values. Let's say 1, 2, 3, 4, 5. 1 is the minimum value. With that one, what you will find with max or what you will do with average, you can't do anything. So terminal operation is 1. After printing, there is no need to do anything. You're getting it. So terminal operator. That's why the name itself is terminal. Terminal meaning is what? End.
So for each is a terminal operator, right?
No. Here the for each is not terminal. Collect is the terminal.
Collect. Okay.
Because for the stream collect, it collected and stored in one list.
Okay. Yeah.
So what this method returns now? Finally, it returns, right? It returns what?
Yeah.
List object. That list object is directly applied in for each. So the for each is not terminal here. But
Okay.
if I remove this, now who's terminal?
For each.
For each is your terminal. Yeah.
Okay.
Because for each is applied directly on whose level? Streams level.
Okay.
But when I bring collect, it's collect on streams, but collect produces what? A list. So for each is applied not on stream. For each is applied in another new instance called list. So
Okay.
at that time, collect is your terminal operation.
Okay, sir.
Any other question? So in the weekend, I mean in the weekday, it's going to be more interesting because we are going to see some live, real object implementations like how we saw in the menu. So like which I have one more use case. We'll use that and see one by one of operations. Do anyone have any other question?
Sir, have you noticed any tricky things in streams when compared to Java 7 collections and streams, like how we see in interface and abstract class? Right, there are
The
more
difference.
similarities, but there is a minor difference in the way they implementing. Right.
Mm. Mm.
So, because this topic is very new for me, like, you ever noticed any tricky things which both are similar, but this teams differs in a particular way?
Streams are differed in particular way is only through lambdas. The biggest difference is streams lambdas. In Java 7, Java 6, it's anonymous class. Since it is anonymous class, you don't have a ready-made method like this. In anonymous class, we write the algorithm, right? In streams, via lambdas, we don't need to write the algorithms for filter. Filter takes the predicate and makes the life easier. So as you said, you have to go to this method, right?
Yes, sir. I want to.
If you look at the filter, okay, stream, the interface is stream. Okay, stream itself is an interface. Okay, the filter, which is again represented as an abstract, which takes a predicate. So who is the operative person here is the person who's going to implement this filter. Okay, so let's say for example, you have a predicate which is passed here, and the filter method is technically it is implemented in the specific collections. Okay, wherever the collections comes in, they'll be using the implementation part of this. But what the filter takes as an input is just predicate. So like which you have multiple methods: map, map to int, map to long, and so on. If we go to this util dot stream, okay, so see only these things you have in the stream. Collectors, rest is all interfaces. Base streams, collector, double stream, int stream, long stream, stream. Base streams is one type of streams that we have seen, but we are working on top of the stream interface. Stream interface is carrying all those methods as its abstract methods.
Yes. Yeah.
And the abstract methods in turn taking the parameter as predicates.
Yes. Okay, got it.
So filters actual implementation is there inside this predicate manipulations. Predicate manipulation is the one that we are actually using. In map, we are using function. In map to int, it is to int function. So like which it goes on.
Okay. So the map, so the function and those implementation is not available in Steam.class. So it is available in another API file, right?
It will be in the collections API. Yes, of course. Yes, correct.
Okay.
Yeah. So just go to list. You can see in the iterable, they have given the implementation for each. You're getting it? We are using for each, right? But here they have given the implementation. Similar like which in every class they might be using the filter implementations. Or in the dynamically, they will be applying the filter. Dynamically, they will be using the map. So obviously, its implementation parts are not known, but we are able to understand that it takes always the function interfaces as an input, because those implementations, dynamic implementations, will all do only the usage of function interface logic. They will only use it as this as a logic. So here sealing is an operation. It's not operations, right? That's why the methods are kept directly as a abstract. So the operations is what we are defining it here. The operations are defined with the help of lambdas and method referencings.
Okay.
Probably if I get to know the source implementation of this, I'll just share it so that you can read those filter, map and collect and see how it is. I'm not sure how to refer to the dynamic rendering of these methods, but if I get a chance, I'll just share that code as well.
Okay, sir. Thank you, sir.
The comparison is also here so that you will notice that. Java 7, this is how we manually write for filter. It's our logic. But here, it's straight away filter method. But the logic is where? That logic what you have written here, the logic what you have written here is what is written here, but it is written in type of what? Lambda. You're getting it, right?
Yes.
So it's simplified. The code becomes more simplified when you're operating on top of the hefty collections.
But we need to before using these things, but I need to go through this filter, map, and collect, and just to get an idea when. So internally, I should get some basic understanding of that. To
Correct. Yes, of course. See, you can only understand what the filter is. Filter is for predicate. So you can use any kind of condition to filter out your number of elements. Out of 20,000 objects, you want to filter it to based on some condition to 1,000. Then it is filter.
yes.
In the sequence, after the filter, you want to further sort it, arrange it. It's not just about filtering 1,000 objects. I want to rank them. Let's say, for example, the state exam is over, and you want to rank them based on first rank, second rank, third rank. You have brought 1,000 students who have scored greater than of let's say 1,000 out of 1,000 to 100,000. So you fetched all the 1,000 people, for example, and out of 1,000 people, you want to rank them in 1, 2, 3 order. Then you'll go for sort. After that ranking, you get all the student details. But what you want to fetch is only the student name or the student school name. You want to fetch the student school name only. In that object, you'll have everything. But you want to fetch only the student school name. You don't want to get the whole object. Then you go for map. Map is for transforming from one object to another object. So what you will fetch? School name, get school name. So from the object, you are extracting only the string. This time it is string, it can be anything. Then you need to go for map. Can I use map first and then go for filter? No, you can't. The order is like this, but you can avoid filter, but order should be arranged. So this you can use it only when you go with more real time, you will start working on it. When you get more real time use cases, then you will, like in my project, I'm working with this frequently in my project. Okay, because we have the use case like that.
Yeah.
But the first level understanding is the moment you think about transforming object, okay, there is a scenario comes in. I want to tweak around this object and extract this object or convert that object data to some other data. Then what should I use? Transformation. Then sure, I need to think of using map. But whether the map to be used first or second, that you should decide based on the flow.
Yeah. Yes. Understood.
And when to use minimum? Minimum is a terminal operation, so I have to use it only at the end.
Yeah.
After getting all the order of work, finally you will get some set of data. From that data, you go for averaging. Then you will use the terminal operation, because all these are standard as an intermediate operation. Is that clear?
Yes, sir. It's clear.
Yeah. Do anyone have any other question? So we have one thing you will be discussing about this, and in the next session we will also discuss about data APIs. Okay, that is also Java 8's new feature. So they have introduced something called java.util inside the util. I'm sorry, java dot. These are the replacements. Okay, replacements for your data API, which we will be seeing. I have some sort of uh, slides which exclusively speaks about date and time API. So we use something called java.time.star to use some set of date implementations. We'll see that. So it's generally we'll be using util, right? Util.date, util.calendar, util.timezone. Instead of that, they have come up with a specific package like java.time. Okay, in order to manipulate for the time implementations. We'll discuss this. So in the connect session, I will again continue with streams. Okay, we'll go more deeper understanding of streams, and again you will have the idea of how to use it. And if time permits, we'll continue with the date. I don't think we'll be having, because just 1 hour. If still it's pending, then probably we'll catch it up on next week Saturday also. But that Saturday will be probably 1 hour, 1.5 hours time. Okay. Okay, I guess if there are no questions, probably we can wind up. It's already 8:10. Any questions? Hope you are clear, right?
Yes, sir.
Yes,
Yeah.
sir.
So majorly we discussed what today is to summarize. We discussed about method referencing, 4 types of method referencing. Then we discussed about interfaces with default methods, static methods, the problems of diamond operators. Then we stepped into the understanding of why we need to have streams, what are the difference between collections and streams, and how do we manipulate the collection data with streams. Okay, so we'll close here. We'll catch it up on either Wednesday or Thursday. I will send you the link. So until then, have a great day. Yeah, thank you.
Thanks.
Thank you, sir.
Thank you.
Thank you, sir.
Bye. Yeah.